All right, so you've been looking into LLMs and all this code generation stuff, and, well, there's a lot of hype around it for sure. But how do these LLMs actually perform when you get down to it? Like when they're dealing with real coding tasks in all their, like, real-world messiness.
That is the question, isn't it? We see a lot of these LLMs being tested on these really simplified coding problems, almost like little puzzles. But does that really tell us how they do building complex software? I don't know.
That's what got me so interested in this new research, using what they call a multi-code benchmark. They took 11, pretty popular LLMs, some you've heard of probably, some maybe not, and they put them through the ringer in 12 different programming domains, 15 different languages. It's a real trial by fire.
What's really interesting about this multi-code bench is that it uses 2,400 tasks. And get this, they're taken straight from popular, high-quality GitHub projects.
So these aren't just like made-up scenarios.
Nope. They reflect real-world code, coding styles even, project
Mhm.
structures, the whole 9 yards.
So it's more like the kind of code you'd run into in a real job.
Exactly. And that's why the results of this study are so much more relevant to how you'd actually use an LLM in your work. And speaking of the results, there were some pretty surprising findings.
Okay, now I'm really curious. What surprised you the most?
I was blown away by this open source model called DeepSeek Coder 33B. It consistently outperformed even GPT-4 in several domains.
Really? Wow, I wouldn't have expected that at all. Everyone just assumes that, bigger models automatically equal better coding. What's DeepSeek Coder's secret?
Well, that's the thing. It seems like size isn't everything. DeepSeek Coder, even though it's smaller than some of the big names out there, it had some real strengths. Like, for example, it was significantly better. We're talking 21.8% better at tasks involving Ethereum blockchain projects compared to like simpler Bitcoin ones.
So maybe it's not just about how big the model is, but about how that size is, like used, the data it's trained on, how it's tailored for specific tasks, all of that.
Exactly. It suggests that we need to be way more, I guess, nuanced in how we choose LLMs for coding. One size fits all might not cut it.
That makes a lot of sense.
Yeah.
So besides that big surprise, any other big trends you noticed? Like areas where LLMs did great and areas where they really struggled?
Yeah, definitely. Broadly speaking, the LLMs did well in like blockchain development, especially Ethereum, as we talked about. And in mobile app development, they also showed potential in certain desktop applications.
So those are the areas where we might actually see LLMs making a difference
Yeah.
just pretty soon. Okay, what about the flip side? Where did they fall short?
Well, web development was tough, stuff involving frameworks like React and Node.js especially.
Kelly, huh?
Yeah. Enterprise app development, all that complex business logic and integrations, that was hard too. And anything using the stats models library, forget it.
Interesting. So even within a specific domain, there's still a lot of variation in how well these LLMs perform. You mentioned earlier that DeepSeek Coder was like generally strong in web dev. Were there any cases where a smaller model held its own against those giants?
Oh, absolutely. Codalama 13b, much smaller, but it did pretty well on those tough React-based tasks. Comparable to DeepSeek Coder, actually.
So again, it's not just about size. The type of training data, the model's design, all of that seems to matter a lot. But let's dig deeper into those failures for a minute. Was it just a matter of them, writing buggy code, or is there something else going on?
The researchers actually took it a step further. They tried to understand the reasons for the failures. They used GPT 3.5's errors as a case study.
Oh, smart. So they weren't just looking at, like, the surface level. They were trying to get at the why. What'd they find?
4 main reasons. First, and this is the most surprising, I think, the LLM often just didn't get what the doc string, those comments that explain what a piece of code is supposed to do, just didn't understand what it was asking for.
So it missed the intent behind the instructions.
Yeah. Second, the LLM often seemed to lack context, like it didn't really understand how the function it was generating fit into the whole code base.
So even if it understood the code in isolation, it couldn't see the bigger picture.
Right. Third, a lot of times it didn't know how to use domain-specific libraries and APIs, the specialized tools, for that particular programming area.
It makes sense. Even if you know how to code, if you don't know the specific tools for a certain field, you're going to be lost.
Yeah. And finally, there were cases where the LLM just didn't grasp the, algorithms or workflows common to that domain. Imagine being a great writer but not understanding the rules of a specific genre. You might struggle to write a sci-fi story if you've never read any sci-fi, right?
Great analogy. It shows how LLMs need more than just general coding skills. They need that specialized knowledge and the ability to actually apply it.
Precisely. If we bring this back to, you, the listener, it means that if you're using an LLM for coding, you can't just give it a prompt and hope for the best. You got to give it the right context. Relevant libraries, APIs, maybe even code snippets from the surrounding project.
It's like giving it a crash course in that specific area of programming before it gets started. Did they actually test this? Giving them extra information, I mean.
They did. They experimented with giving the LLMs different types of additional context. The results, pretty promising.
You can't just leave it at that. Tell me more. What kind of context? What kind of impact?
Well, they tried a few things. They added import statements from the file, gave the LLM code snippets around the function it was supposed to write. They even provided definitions of project-specific APIs.
So basically, all the information the human developer would have.
Exactly. And the good news is this API and dependency context really helped most of the models, like giving them a cheat sheet.
Makes sense. But there's got to be a catch.
Of course. Turns out sometimes too much code, like the whole file's context, overwhelmed the smaller models. Hurt their performance, actually.
So too much context and the LLM gets lost.
Yeah, exactly. It seems like finding that sweet spot, enough context but not too much, is key.
Okay, let's pause for a second. We've covered a lot. So far, we've learned that LLMs show some real promise for coding, but they're not magic. Bigger doesn't always mean better. Domain-specific knowledge and context, really important. And that context can make a huge difference, but too much can backfire.
Great summary. And it leads us to a big question. If this study measured LLMs on today's projects, how are they going to handle the even more complex software of tomorrow?
Right. What kind of training data, what kind of tools are we going to need to keep these LLMs relevant and effective as software development changes?
Well, that's what we'll get into next time. We'll explore all the implications of these findings and discuss what the future holds for LLM-powered coding. Welcome back.
I'm still kind of reeling from those MultiCodeBench results. It's so cool to see, like, such in-depth analysis that really pushes how we think about these LLMs.
Totally. And like we were talking about earlier, there are just so many implications to explore. This research, it gives us a snapshot of how they're doing right now, but software development, it's always moving, right?
Exactly. It's almost like, are we just seeing the very beginning of what these models can do? Or what they could do, like, really soon?
Exactly. Think about how fast everything changes. Languages, frameworks, even whole approaches to development. What worked 5 years ago is, like, ancient history now.
Before we get too far ahead of ourselves, I want to go back to some of those specific strengths and weaknesses the study found. Like, we talked about DeepSeek Coder and how well it did with Ethereum. Any idea why that might be?
That's a good question. One possibility is that DeepSeek Coder was trained on, a data set that had a lot of Ethereum code, so it had a deeper understanding of that specific, like, language, libraries, all the patterns used in that area.
So it's like it had a head start in the Ethereum world compared to models trained on more general code.
Exactly. Another possibility is that DeepSeek Coder's architecture, the way it's designed, might just be particularly good at understanding the complexities of blockchain tech.
I see. So it could be the data, the design, maybe both.
Mhm.
Okay, what about the areas where LLMs struggled, like web dev? Why was that so hard for them?
Web development is a beast, right? It changes so fast. Frameworks and libraries are always evolving. It's possible that the training data they used, it just didn't have enough examples of the latest stuff. Or maybe the models themselves, they're just not designed to keep up with that pace of change.
Makes sense. Thinking about the future then, how do we make sure these LLMs don't, like, become obsolete? What needs to happen with the training data to keep them relevant?
We need a constant stream of new, good quality code. That's the main thing. LLMs are, they're like sponges. They soak up patterns and knowledge from the data, so that data has to reflect what's happening now, the latest and greatest.
So it's not just quantity, it's quality, keeping things updated. Are we talking about, like, constantly scraping GitHub, or is there a more, I don't know, strategic way to do it?
It'll take a few things, probably. Constantly updating the data sets. Yeah, pulling from active repositories, that's key. But also curating that data, prioritizing certain domains or languages, and even like incorporating code that shows best practices, security standards, that kind of thing.
Oh, that's huge. We don't want these LLMs learning bad habits, spitting out code that's, like, full of security holes.
Right. Ethical implications are a whole other discussion. But yeah, for now, let's stick with the data itself. We talked about keeping it fresh, but what about making it more intelligent?
Okay, intelligent training data. Now I'm really curious. What does that even mean?
Imagine, instead of just the code itself, we also give the LLM metadata about it.
Yeah.
Like, what's the purpose of the project? Who's it for? What design patterns are used? Even comments, documentation written by humans.
So we're giving it more context, not just about the code, but the why behind it, the thought process.
Exactly. This richer context, it could help them understand the whole software development process better. And then they can generate code that's not just correct, but well-structured, maintainable, aligned with what humans actually want.
That's a game changer. It's like they go from code monkeys to like actual coding partners.
Coding partners. I like that. And to take it even further, imagine incorporating user feedback into the training too.
So it's this constant learning loop. The LLM gets better over time
Ugh.
based on how developers actually use the code and the suggestions they make.
Right. A future where these LLMs learn from mistakes, adapt to different styles, even anticipate what individual developers need. Super powerful stuff.
This is getting a bit sci-fi, but I like it.
Yeah.
Okay, let's shift gears for a second and talk about tools. We've been focusing on the data side, but what about other techniques that can help LLMs keep up with the ever-changing landscape of software development?
One area that I think is really promising is what they call meta learning.
Meta learning. Sounds kind of intimidating.
It's not that complicated, really. It's basically teaching LLMs how to learn. Instead of just giving them knowledge, we give them the ability to, acquire new knowledge.
So teach them how to fish and all that.
Exactly. With meta learning, you can train them on a whole range of tasks, programming styles, so then they can generalize to new domains, new languages, even stuff they've never seen before.
So instead of being like specialists in one area, they become more generalists, able to pick up new things easier, which seems pretty important given how fast things change.
Exactly. Meta learning, it can help them stay flexible, adaptable.
Makes a lot of sense. Any other tools or techniques that you think will be important for, this whole future of AI coding?
Another area that's getting a lot of attention is integrating LLMs with other AI systems, like symbolic AI.
Symbolic AI, okay. Interesting. What's the thinking there?
Well, LLMs are amazing at pattern recognition, generating human-like text, but they can struggle with logical reasoning, understanding complex relationships between concepts.
And that's where symbolic AI comes in. It's more
Yeah.
structured, rule-based. Right?
Exactly. If you combine their strengths, LLMs, with symbolic AI, you could create these hybrid systems that are both creative and logically sound.
So the best of both worlds. The LLM throws out suggestions based on all its knowledge, and then the symbolic AI is like the logic checker, making sure it makes sense, maybe even optimizing the code.
Yeah, exactly. This could lead to a whole new generation of coding tools that are way more powerful, way more reliable.
This is so cool. It really feels like we're on the verge of something huge.
I agree. LLMs have so much potential, but we have to be smart about it. Ethical, thoughtful, and really focus on this collaboration between humans and AI.
Well said. I'm sure we'll be back to explore all this more in future deep dives. But for now, let's take a break and come back for our final segment. We'll really dig into what this research means for, well, the future of coding. All right, welcome back to our final part of this deep dive. We've talked about the MultiCodeBench study, how well some of these LLMs did, even looked ahead at the future of, AI coding. It kind of feels like we're at this really pivotal moment for software development.
It's definitely exciting, that's for sure. And as we wrap up, I think it's important to zoom out for a minute. Think about the big picture, What does all this research tell us about the future of coding? And what about the role of actual human developers? Because things are changing fast.
Yeah, that's the question everyone's asking, right? Are LLMs going to take over completely? Or will they become our coding buddies? There's so much out there, and honestly, I'm both excited and a little, I guess, nervous about what's coming.
I think that's totally natural. It's easy to get caught up in the extremes, Like doom and gloom, coders are all going to be out of a job, or this utopian thing where AI solves everything. But I think the truth is probably somewhere in the middle. LLMs are incredible, right? But they're still just tools. They can automate stuff, help us with tough problems, even suggest creative solutions. But they don't have that critical thinking, the problem solving, the deep expertise that humans have.
So it's not about humans versus AI. It's more like humans and AI working together.
Exactly. It's about finding that balance, where LLMs make us better, not replace us. Imagine a world where developers can offload all that tedious stuff, debugging, figuring out APIs, give it to the LLMs. That frees up humans to do the big picture thinking, design, innovation, solving the really hard problems.
And that's feature I like. But it makes you wonder, what skills are developers going to need to like really succeed in this new world with AI playing such a big role?
Great question. I think, first of all, being able to talk to these LLMs clearly and effectively is going to be huge. We've seen how important it is to give them the right context, to get good code out of them. So developers who can explain what they want, give the background info, even guide the LLM's thought process, they're going to have a real advantage.
So it's like learning a whole new programming language almost, the
Yeah.
language of how to talk to these AIs.
I like that. It's like
Oh,
Python or JavaScript, right? You got to learn the syntax, the rules. Same with LLMs. You got to learn how to communicate with them, how to, I guess, guide them to get the results you want.
and it's not just writing prompts. It's about understanding what the LLM is good at, what it's not so good at, knowing when to trust it, when to be a little more skeptical.
Definitely. Developers who can really look at that code, the code the LLM generates, spot potential issues, biases, and then actually refine it based on their own knowledge. That's going to be super valuable.
So it's not about just blindly trusting the AI. It's about being like a good editor, a collaborator.
Exactly. And that leads to another important skill, being able to evaluate code no matter where it came from. Human, LLM, whatever. You gotta be able to assess it. Is it correct, efficient, secure? Those fundamentals, they're not going anywhere.
It sounds like those core skills are almost even more important now in this new world of AI coding.
I think so. And finally, being adaptable. Being a constant learner, that's going to be so crucial. Software development is always changing, and with AI in the mix, it's going to change even faster. So the developers who are curious, open to new things, willing to embrace new tools and tech, they're the ones who are going to really thrive.
So it's not just about the specific skill set. It's about like a mindset, one of continuous learning.
Absolutely. The future of coding, it's a journey, right? Not a destination. And it's those who are ready to embrace that journey, learn from everything, the good and the bad, and work with AI, not against it. Those are the people who are going to shape this future.
That's a great way to put it. It's clear that these LLMs are going to have a huge impact.
Yeah.
But it's up to us, the humans, to figure out how to use them right, responsibly, effectively. And we'll definitely be back with more deep dives as this whole thing continues to develop. Thanks for joining us.
It's been great diving deep with you.